So for this video, I'm going to be doing exactly what the title says, and I'm going to be turning toilet paper into drinkable alcohol. I don't know exactly where this idea came from, but about 6 months ago, I became convinced that this conversion was possible. This is because toilet paper, and well, pretty much all paper, is made almost entirely of cellulose. Cellulose naturally occurs in almost all plants, and we use it to make everything from cotton clothing to paper or cardboard. What I've always found interesting though is that at the core of it, it's just a chain of simple glucose sugar molecules. Sugar is something that we usually associate with food, but in cellulose, the glucose units have been strung together in a very specific way, which gives it completely different properties. This has always blown my mind because it means that our clothing and almost all paper is basically made out of sugar, and wood is also about 50% cellulose, so a lot of our houses are also kind of made out of sugar. For the most part though, cellulose is very resistant to degradation, and the glucose is mostly inaccessible. However, the fact that some animals and microbes have developed ways to break it back down into glucose told me that there had to be a way that I could do it. Based on this, my dream was to start with a cellulose source like toilet paper and then somehow chop it up to make a solution of glucose. Into that, I could then throw in some brewer's yeast to turn it into alcohol, and then I could distill it to make some weird toilet paper moonshine. The biggest challenge of this project was of course the first part, which was breaking down the cellulose. To do this, there were two main ways, either chemically or enzymatically, and both of them had their own pros and cons. The chemical method was more efficient, but it involved using a lot of acid, which would be hard to separate from the sugar after it was done. I would have most likely ended up having to neutralize all the acid, and I figured that this would both be wasteful and kind of messy. The enzyme method, on the other hand, appeared to be less efficient and even take longer, but from what I could tell, it was a lot cleaner and much easier to set up. After thinking about it for a good while, I felt that I liked the enzymatic way better, so the next thing that I had to do was buy some enzyme. The enzyme that I needed to break down the cellulose was called cellulase, and the cheapest source of it that I could find was from a company called the Alchemist's Pantry. They were a brewing company, and it was all supposed to be food-grade stuff, so it was almost perfect, and I bought a bag of it. It also clearly stated that all the cellulase came from yeast and not bacteria, and I'll explain why this was important later on. But anyway, the enzyme was being shipped from Europe, and it was going to take a few weeks to arrive. So, while I was waiting for it, I figured that it was a good time to actually put together the process that I was going to be doing. It honestly took me a while to figure it all out, but after a bunch of research, I eventually came up with something that was relatively simple. To do it, all I needed was some basic equipment and a few easy-to-get chemicals. When the enzyme eventually arrived, I considered doing some small-scale tests to verify that what I came up with worked, but it was such a simple process that I decided to just wing it and go all in. If it ended up working, it would save me a lot of time, and I figured that at worst, I'd have a bunch of sad failure footage that could be used for something. So now, to get started, the first thing that I needed was some toilet paper. I'm pretty sure that almost any brand would have worked, but I specifically went with the one with the fluffy kittens on it. Toilet paper is one of the least densely packed forms of paper, which means that it has a lot of potential surface area for enzymes to attack it. However, this doesn't necessarily mean that it's easier for enzymes to break it down. At the molecular level, the cellulose fibers are still tightly packed together, and it's hard for cellulase to do anything. If I just directly mixed the enzyme with the toilet paper, not very much would happen, and it would probably make little to no sugar. To fix this problem though, it wasn't very hard, and I just had to pre-treat the cellulose with a dilute base. So, I got out a large pot, and into it, I added 3 liters of distilled water, followed by 60 grams of sodium hydroxide drain cleaner. This would give me roughly a 2% base solution, and I stirred it until everything dissolved. Then, I slowly added 1 entire roll, and as you would expect with toilet paper, it quickly started soaking it up. After about 10 seconds, it was completely full of water, and I tried to break it up as much as I could. I also pulled out the cardboard tube from the center because I wanted to keep this purely just toilet paper. I was eventually left with a nice and mushy toilet paper stew, and the next thing to do was to basically cook it. To do this, I just put it onto a cheap IKEA induction heater, and I cranked up the power. It all slowly heated up, and when it eventually got to a boil, I turned down the power to keep it at a light simmer. I tried stirring it often to prevent it from splashing, but it didn't really seem to help. It apparently just loves splattering boiling hot water everywhere, and I found that putting on the lid was absolutely necessary. The goal here was to try to keep it under control and to have it simmer for about an hour and a half. Under these conditions, the cellulose fibers were being attacked by the base and getting partially degraded. This caused a lot of the bonds between the fibers to be broken, which allowed them to separate and become less densely packed. It was also chopping up the cellulose fibers into smaller pieces, and their average length was going down a lot. This created more shorter length fibers, and this was important because it meant that there were more open ends. The cellulase enzyme can only degrade the fiber from the end, and by making more potential areas of attack, it should make it go a lot faster. In summary though, the major effect of this base treatment was that it was separating the fibers and chopping them up. By the time it was done, the whole thing had turned yellow, and it had a very distinct smell to it. I honestly thought that it was going to be horrible, but it was surprisingly pleasant. I'm not exactly sure how to describe it, but it was kind of sweet and woody. I took it off the heater and I let it cool for about 30 minutes, and when it wasn't crazy hot anymore, I filtered off all the paper. What I was left with in the strainer looked a lot like some bad mashed potatoes. In the container below it was all the water, and without the paper, it had a much darker orange-brown color. What I had to do now was wash it with a lot of distilled water to get rid of the base and as much of the color as possible. I tried doing this a couple times directly in the strainer, but it just wasn't very efficient, and most of the paper barely got washed. So what I did instead was clean the pot from before and dump everything back into it. In here, I was able to add a lot more water, and I was able to thoroughly mix around the paper to make sure that it all got washed. This was then poured back into the strainer, and after doing it just once, it was already looking pretty good. I ended up doing this one more time, and then I just did several crappier washes directly in the strainer. When I eventually felt that it was good enough, I tried squeezing out as much of the water as I could. At this point though, the container was quite full with water already, and it was hitting the bottom of the strainer. So, I just continued doing it over the pot, and this was what I was eventually left with. This pre-treated paper was now good to go, but I wasn't quite ready to get things started, and I still had to make the enzyme solution. To do this, I first had to make an enzyme concentrate by adding 90 grams of the enzyme powder that I got earlier, and then bringing it up to about 400 ml using distilled water. I then stirred it around, but a lot of it didn't want to dissolve because most of this enzyme powder was just filler. It's pretty common for enzymes to be dispersed on inert fillers, and in this case, the fillers were cornstarch and maltodextrin. The cellulase enzyme itself and most of the maltodextrin dissolved into the water, but the cornstarch was pretty much insoluble. When I was planning this project, I was a bit concerned because both cornstarch and maltodextrin are also glucose-based sugars. I was worried that they might also end up getting broken down into glucose and turned into ethanol, but this actually isn't an issue. They don't get attacked by the cellulase, and the yeast, in the fermentation step that I'll be doing later, aren't able to break them down either. I even confirmed this by doing a separate control run, but I'll talk about that later in the video. Because these fillers were inert, I could have just directly used this mixture as it was, but I wanted to clean it up a bit and to get rid of the cornstarch. Filtering cornstarch though is almost always a nightmare, and instead, I just covered the top and I let it sit in my fridge overnight. By the next morning, it had pretty much all separated, and this enzyme concentrate was now good to go. To make the actual enzyme solution though, I had to dilute this concentrate in something known as a buffer solution. A buffer solution is something that's commonly used when working with enzymes, and it helps keep the pH at a specific level. This is important because enzymes are very sensitive to pH and they work most efficiently in a certain range. The cellulase that I had was from yeast, and the optimal pH for it was 5, so that was what I had to make the buffer at. There are many different chemicals that can be used to make a buffer, but a very easy and common method is to use citric acid and sodium citrate. Both of these are common food additives, and I was able to easily find them at a local store. I also found a calculator for making this buffer online, and all I had to do was plug in the pH that I wanted, the concentration, and the total volume that I was going for. Based on my research, a total of 3 liters seemed ideal, with a pH of 5 and a molarity of 0.05. After plugging this in, it told me to use about 25 grams of the sodium citrate and 12.2 grams of the citric acid. So, into a large mason jar, I added 2.6 liters of distilled water, followed by the citric acid and the sodium citrate. I stirred it around until it all dissolved, and into this, I poured the enzyme concentrate from before, which brought it up to 3 liters. I tried to leave as much of the cornstarch as I could in the beaker, but some of it was still able to make it in. Now after all this, the enzyme solution was finally ready, and all I had to do was add the toilet paper. When it was all in there, I mixed it around as thoroughly as I could, and I loosely covered the top. I then took this whole thing and I put it into an oven that was set just slightly above 50°C. This was the optimal temperature that this cellulase worked at, and I had to leave it in there for 2 days. Over this time, the enzyme should be attacking the cellulose and slowly turning it into glucose. When it comes to cellulase though, it usually isn't just one enzyme doing everything, and it's actually a group of a few different ones, all working together. The first one is endocellulase, and it breaks the bonds between the fibers and within the fibers themselves. By pre-treating the paper with a base though, a lot of these bonds were already broken, and the ones that remained were a lot easier to access. The liberated fibers were then attacked by the exocellulase, which degrades them from their ends. So what it does is bind to the end and travel along the fiber and chop off groups of 2 or 4 glucose units. These much smaller sugar units are then finally broken down into glucose by another enzyme called cellobiase. When I checked on it the next day, the paper had all floated to the top. I then stirred it, and compared to before, it was definitely a lot thinner and fluffier. The cellulase had clearly done something to it, and so far, it was looking a lot better than I expected. I checked on it again about half an hour later, and it had separated, where most of it stayed floating. The stuff at the top was slowly falling down though, and over the course of the day, most of it ended up at the bottom. I left it until the next day until it hit the 48-hour mark, and this was what I had. There was still a bunch of stuff left over, but it didn't at all resemble the toilet paper that I started with. It was done at this point, so I took it out of the oven, but before moving on, I had to let it cool down. It was currently somewhere just above 50°C, but I needed it to be closer to 35. This was going to take about an hour though, and in the meantime, I poked around at it a bit. I was honestly really impressed with how fine and fluffy it was, and like I said before, I really didn't expect it to work this well. I'm really not sure exactly how much paper was still left here, but I feel like it was probably around 10 to 20% of what I started with. However, that's almost just entirely speculation on my part, and not really based on much. When it eventually got to 35°C, it was time to add the yeast. When it comes to fermenting sugar to make alcohol, there are a lot of different yeast strains to choose from, and each of them have their own pros and cons. However, in my case, I wasn't doing anything very fancy, so I just went with common brewer's yeast, which can tolerate many conditions. These conditions though, at least in terms of pH, were actually kind of ideal. As I mentioned earlier, the cellulase that I was using originally came from yeast, so the pH was already tuned to be optimal for yeast. This was why I didn't want to use a bacterial cellulase, because then I would have had to readjust the pH. The yeast in the packet was dehydrated, and right now, they were all getting rehydrated and coming back to life. I then snapped on the plastic adapter that the jar came with, followed by the lid that I had modified. I had cut a hole in it to fit a stopper and an airlock so that it could prevent air from getting in and to also help track the progress of the fermentation. Initially, not much appeared to be happening, but then, very quickly, a lot of yeast flakes started floating to the top. They were being carried by the CO2 gas that they were producing, which gave them some buoyancy. When they got to the top though and released the CO2, they would then sink back down. This cycle continued for a while, but it didn't last forever because the yeast were slowly being dispersed into the water. By the next day, it was just a murky looking mixture and there were no pieces floating around anymore. It was also generating a lot of CO2, which was a very good sign because it told me that the yeast were happily eating away at sugar. How much sugar was actually there though, I had no idea, but it was definitely working, at least to some degree. I then looked at the airlock and it was letting a bubble out about every 30 seconds, which was a pretty decent rate. What I had to do now was basically nothing, and I just had to wait until it completely stopped bubbling. When this eventually happens, it would mean that there was little to no sugar left, and I figured it would take about 2 weeks. I didn't just leave it where it was though, and I put it in the oven that I used before, and I kept it just above 30°C. This was about a week later, and the amount of paper at the bottom had gone down quite a bit. This was because I had never deactivated the cellulase, and it was still slowly attacking the cellulose. It wasn't as efficient because it was around 30°C instead of above 50, but it was still apparently working. In terms of bubbling, it was much slower than before, but it was still clearly going on, so I put it back in the oven and I waited another week. So I came back a week later, and when I checked on it, the airlock wasn't moving at all, and I couldn't see any bubbling going on. At the bottom, there was still some white stuff, but I wasn't sure if this was leftover paper or just a bunch of yeast. At this point, I considered it done, and now, the next thing that I had to do was distill it to get out the ethanol. I didn't want to include all that questionable stuff at the bottom though, so I poured everything into another container. The bit that was still there was then dumped into a coffee filter. This filtration was really slow, and it wasn't really worth waiting for it to finish. The liquid that did eventually pass through though would all be added back to the main batch. But anyway, with all that done, I could start setting up the distillation. When most people distill alcohol, they use a large and specialized setup for it, which is the most efficient thing to do. However, I just decided to do it in glassware because my scale was relatively small and I thought that it would look nicer. Almost all my glassware had been used before, so to keep this food safe, I bought a fresh set from eBay for about $55 Canadian. The biggest flask that it came with though was only 1 liter, so I'd have to distill it in multiple batches. To get things started, I added a stir bar, and then I poured in the alcohol solution. In general, it's best not to go much over the halfway point, but I wanted to get this done in the fewest batches possible, so I ended up pushing it a bit. Above the flask, I put together the rest of the setup, and to do this, I used a fractional column, a thermometer, a condenser, and a beaker. I then turned on my water circulator, and I got some cold water flowing through the condenser. At this point, it was good to go, so under the flask I added a heating mantle, and I turned on the heating and stirring. As it warmed up, it started bubbling a lot, but it wasn't boiling, and it was mostly just CO2 gas getting kicked out of solution. The color also shifted to being much whiter, and I think this was caused by yeast coming out of suspension. Some frothing started happening, and it didn't look like it wanted to disappear, and this was going to be a problem. So I turned on the heating to try to prevent a disaster, but it was a bit too late. The foam had already started climbing the column, and it wasn't really slowing down. It was able to make its way all the way to the top of the column, and then suddenly, it started actually boiling, and it launched a bunch of liquid through the entire setup. This was a bit of a pain, but it wasn't the end of the world. It just meant that it was going to take a bit longer, because I now had to recycle everything here in the next batch, and also, I had to be a bit more careful with the heating. When it eventually looked like it was under control, I covered the flask and the column with some aluminum foil. This helps insulate them, and it makes it easier for the vapor to climb the column and make it to the condenser. I also swapped the beaker, but the stuff coming over was still pretty murky because it was picking up all the solid junk that was carried up the column before. This run was definitely turning out to be way messier than I expected. I was hoping that this stuff would be nice and clear, but that obviously wasn't the case, and I was going to have to recycle this as well. It wasn't a total loss or anything though, because the alcohol coming over was definitely a lot more concentrated than it started at. It just didn't look very nice. However, it was still mostly just water, and it had other volatile stuff mixed in as well. To really clean it up and to properly concentrate it, I'd have to do a second or maybe even a third distillation. The reason that the stuff coming over was mostly water was because I was only starting with a very low concentration of ethanol. In my fermentation mixture, it was probably at most something like 2% ethanol, and that meant that it was 98% water. At the very beginning, the stuff coming over was probably close to 50 or 60% ethanol, but after that, it quickly and continuously dropped. This happened because as the ethanol was boiled off, that 2% concentration was constantly decreasing, and the relative amount of water was constantly increasing. This caused more and more water vapor to be let off with the ethanol, and the stuff that I was receiving eventually became almost entirely water. This meant that I couldn't really trust the thermometer because the temperature was heavily skewed to the boiling point of water. However, even though it was well above the boiling point of ethanol, which is around 78°C, there was still some ethanol coming over once it was up at around 98. Usually, temperature is the best thing to go by, but because I couldn't use it here, I had to go with the more traditional way. So, to know how close it was to being done, I just occasionally tasted what was coming over and tried to tell if there was any ethanol in it. As I said before though, along with the water and ethanol, there's other volatile stuff coming over with it, which doesn't really make it taste very good. It wasn't as bad as I expected it would be, but I did end up spitting out most of what I tried. At some point, I couldn't taste any more ethanol in it, and then I continued collecting it for several more minutes. After this, I considered it done, and pretty much all of the ethanol should have been extracted. Everything left in the boiling flask was just waste, and after letting it cool for a bit, I poured it down the drain. This was one of the rare times where it's okay for me to do this, because unlike a lot of the chemistry that I often do, there was nothing toxic or dangerous in this. This was everything that I'd collected, which was not very pretty to say the least, and like I said before, was just going to be recycled. So, I reattached the now empty flask, and I poured them in. I then added more of the other stuff, and I set it all up again. This time, I was super careful with the heating, and there wasn't a disaster. This time, because it was going to be a lot slower, I expected the ethanol coming over to be more concentrated, and I started with just a small vial. However, after a bit, I realized that I was going to be collecting a lot more than this, and I swapped it out for a mason jar. Then, just like the other run, I did it until a taste test told me that there wasn't any more alcohol coming over. And when it was done, I emptied the flask, filled it with fresh stuff, and just kept it going. It was all going really well all the way up to the last batch, and everything that I had was nice and clear. However, for some reason, it of course decided to go crazy right when I was close to the end, and it spit over a bunch of that white junk. This wasn't a huge deal though, because I planned to do a second distillation anyway, but it was still kind of sad. This whole distillation process was way slower than I expected, and it took me a few days to finish. At this point though, it was finally done, so I took away the mason jar and I dumped out all the stuff in the flask. What I had now was less than 10% of the volume that I started with, so it was way more concentrated than before. As a quick test, mostly just for fun, I decided to try lighting it on fire. However, it still wasn't concentrated enough to ignite, and not very much happened. I honestly wasn't very surprised by this though, and now, to actually find out its concentration, I poured it all into a grad cylinder. I then dropped in a hydrometer, which will float at different heights depending on the density of the liquid. When there's more ethanol, the density will be lower, and this meter will be able to sink deeper. In this case though, it didn't go very deep at all, and it told me that the concentration was around 20%. This was way higher than I ever imagined getting from this project, and 250 mils of 20% alcohol really isn't bad at all. I was hoping to maybe get 5 or 10 mils of pure alcohol, but based on this, it's telling me that there's more like 50. But anyway, at this point, if all I was looking for was to drink some dirty toilet paper wine, I could have stopped here. However, based on the taste test that I had to do, this wouldn't be a very pleasant experience. To make it even remotely tolerable, I had to distill it again to get rid of all that solid junk and to purify it. Besides ethanol, there were a lot of other volatile and bad tasting things in there. When it was super dilute, it was very difficult to get rid of them, but now, with another distillation, I should be able to get rid of almost all of them. This time, I had a lot less liquid, so I could do it in a smaller flask, and all in one batch. I also completely cleaned and scrubbed the rest of the setup to make sure that it was as clean as possible. I then set it up like before, but this time, the heating mantle was a bit oversized. This was okay though, and it would just make the heating a bit less efficient. However, with most of the yeast and most of the other stuff gone now, there shouldn't be a problem with bubbling or foaming. At this point, I was just about to get things started, but then I realized that I totally forgot the stir bar. So, I just quickly popped it open again and dropped one in, and then I turned on the heating and stirring. After this, I covered everything with foil, and I waited for stuff to start coming over. One major difference between this distillation and the last one was that there was way less water, so I could actually pay attention to the temperature. The first drop showed up at around 70 C, and then it slowly rose to 79 C, where it remained constant. This initial amount was called the foreshot, and it contained almost entirely low boiling point side products. In this section, if it were present, most of the methanol would come over, but I don't think that there was any here. This is because methanol is only produced when certain foods are fermented that contain sugars called pectins. I started with nearly pure cellulose though, so there was no real reason for any of it to be made. As I kept collecting it at 79 C, it slowly got into the portion called the heads, which was mostly ethanol, but it still had some other stuff in it. I kept catching it in the same vial as the foreshot for a bit, and then I swapped it to a beaker to get the rest. As more came over, it slowly moved to the section called the hearts, which was almost pure ethanol. Along with the ethanol though, usually comes some other things which actually taste good, and it makes this portion the most valuable. I was tracking everything, again by occasionally tasting it, and at this point, it was quite pure and probably around 85%. Like before though, there was still a lot of water in the boiling flask, and the amount of ethanol that was in it was constantly decreasing. So the stuff that I was collecting slowly got less concentrated, and the temperature also slowly increased. As this happened, higher boiling point side products were being carried over with the ethanol, and it was changing the taste. This portion is near the end of the distillation, and it's commonly known as the tails. However, I didn't ferment anything complex like fruit, so for this section, there weren't many side products that could come over. To me, the only thing that I noticed was that it was getting more dilute, and maybe a bit bitter. When making moonshine, distillers usually don't collect everything in one container, and they try to separate the different sections. Both the heads and the tails contain a lot of ethanol, but they often have a bunch of weird stuff mixed in, so they're often just included in future runs. The hearts, like I said before, are the most valuable, and they contain the best tasting portion. Knowing exactly when to start collecting the hearts and when to stop is one of the most important things when it comes to making a good quality product. I, of course, wasn't making a typical moonshine though, and I felt that my ethanol was a bit too precious to discard any of it. This was why I just chose to collect everything in one beaker. Also, like I said before, I was starting with a relatively pure sugar source, so there weren't that many side products that could be made. When it got to around 80 mils, the temperature was about 99 C, and I didn't taste ethanol anymore, so I considered it done. This was everything that was left in the boiling flask, and like all the other runs, I waited for it to cool, and then I got rid of it. The final result of this was 80 mils of an unknown concentration and this little vial of the foreshot. I'm not sure how to describe it, but the foreshot really didn't smell very good, and I just threw it away. Now for the good part, I wanted to know how concentrated it was. Instead of just doing it with a hydrometer though, I again tried lighting it on fire. This time, it ignited really easily, and it burned with that blue flame that's typical of ethanol. I was really happy that this worked, but it didn't really tell me much of anything about what the concentration actually was. To get an accurate number, again, I just had to use a hydrometer. The volume here was really low though, and my current setup couldn't do it, so I had to buy a smaller one. However, at first, this one also looked like it was still too big. When I looked at the bottom of it much closer though, I saw that it was actually floating. So, the reading on here should be fine, and it told me that it was about 64%. This was more or less what I was expecting to get, and I felt that 64% was decent for a moonshine, and I didn't have to distill it again. So at this point, it was pretty much done, and I poured it all into a little jar, and I labeled it appropriately. At 64% and about 78 mils, this was equivalent to 50 mils of pure ethanol, and like I said before, it was way more than I ever expected. I started with 100 grams of toilet paper, and assuming that 100% of that mass was turned into glucose, the maximum yield was about 60 mils. This meant that this whole process was 83% efficient, which to me was suspiciously good. This got me worried that maybe the maltodextrin or the cornstarch that was added along with the enzyme was breaking down as well. Theoretically, cellulase doesn't attack either of these sugars and yeast can't ferment them, but I had to make sure. So I ran a control by repeating the exact same process, and I just didn't include any toilet paper. When I distilled it all, I did actually get some ethanol, and my final yield was 20 mils of 20%. This meant that there were 5 mils of pure ethanol, and this likely came from the maltodextrin, which can sometimes have a small amount of fermentable sugar in it. So, it was contributing some ethanol, but pretty much all of it was still from the toilet paper. If 5 mils were coming from the enzyme though, then my real yield was 45 mils and not 50, and my actual efficiency was about 75%. In my opinion, this was still shockingly good, and even though I did everything myself, it's still kind of hard to believe that it all came from toilet paper. But anyway, now that I had actually made it, the only thing left to do was to see how it tasted. While I was distilling it, I individually tasted each section, but now that it was all combined into one, I was really curious to know what it was like. Okay, so to get started, I'm just going to smell it. And I mean, there's nothing gross about it, but also nothing really very special. It kind of smells like vodka, except with a bit of extra, maybe not good other stuff in there, which again, as I mentioned before, probably comes from either the heads or the tails. But it's not bad overall. And I guess I'll just taste it now. I mean, it's really strong because it's 64%, but it doesn't taste very bad. It's a little bit bitter, which I kind of got when I was tasting the tails when I was making it. Other than that, I don't know. I'm honestly not the best person to really review it because I don't drink alcohol often, and I honestly don't really like the taste of alcohol. But compared to vodkas and other stuff I've had in the past, this wasn't that much worse. There was, again, that little bit of a bitter taste, and maybe some off taste that came from the heads, but besides that, I mean, it wasn't too bad. If I were just served it, I would think that it's just generic alcohol, which I hate anyway. I'm not gonna add that part. But anyway, this about brings me to the end of this project. When I first came up with the idea for this, it was mostly just a funny concept, and I had no idea that it was actually gonna work this well. I was honestly hoping for maybe 5 mils, and it's probably the first time ever that a project has turned out this much better than I expected. Also, even though I'm really not a fan of alcohol, the flavor wasn't bad, and overall, I'm still shocked at how well it all turned out. For all the alcohol that I still have left over, I would have loved to do a giveaway, but I doubt that it would be legal. So, I'm just going to be keeping it as a souvenir, and maybe I'll try to use it in a future video. It took me a lot longer than I expected to put this all together, so my video schedule is a bit weird now, but I do plan to get another one out around mid-December. I don't want to give any details of what it's going to be about, but this next one is also a funny concept that I'd been working on for a while. It's also kind of food-based too, so there will be some more tasting going on. Before I go though, I want to quickly mention Team Trees, which I'm sure a lot of you guys have already heard about at this point. For those that haven't though, it's a tree planting initiative that was started by Mr. Beast and Mark Rober. It's a massive YouTube collaboration, and every dollar that's donated will plant one tree somewhere around the world, and the goal is to get to 20 million. At the time of editing this, they're less than 5 million away, and if you want to help, you can do this by either donating or picking up some of their merch. And just as one last thing, I don't mention my other social media here very often, but I am also on Twitter and Instagram. On both of these, I often post content that never makes it to YouTube, and sometimes I also share some high-quality stuff like this. As usual, a big thanks goes out to all my supporters on Patreon. Everyone who supports me can see my videos at least 24 hours before I post them to YouTube. Also, everyone on Patreon can directly message me, and if you support me with $5 or more, you'll get your name at the end like you see here.